Section 1.5, Inequalities. We're going to solve linear inequalities first, and then we are going to solve nonlinear inequalities after we do a few examples of linear inequalities. It's almost exactly like solving an equation, except when you divide or multiply by a negative, you change the sense or the direction of the inequality. So the first problem, I can move this x over by subtracting x, and then I can move the 5 over by adding 5, and then I can divide by 2. So here's what the graph looks like. And if I want to write it in interval notation, negative infinity to 7. The next one, I'm going to subtract 8. I'm going to divide by negative 2. Notice when you divide by a negative 2, the direction changes. So now here's a graph of this one. And in interval notation, this one is negative infinity to 1. But it includes the 1, so that's why it's the squared off bracket. The first one did not include the 7. Solve example 3. Multiply each side, or everything, by 4. 4, 4, and 4. So when I multiply the first by 4, I have negative 2. When I multiply this by 4, this will cancel, and you'll have 2 times 2 is 4x. 2 times negative 3 is minus 6. Distribute, you'll have 5. Add 6. Divide by 4. So you have 1 is less than or equal to x is less than 11/4. In interval notation, it includes the 1, so it's a squared off bracket. It does not include the 11/4, so it's the rounded. Example 4. Remember what that negative exponent means. It means 1 over. The only way that this can be less than 0 is if the denominator is less than 0. So we can just rewrite this and solve it like that. You cannot multiply each side by 2x minus 8 because you don't know the direction of that. You don't know if 2x minus 8 is a positive number or a negative number. So you don't know if that less than switches direction. Add 8 to each side. Divide by 2. X is less than 4. Interval notation, negative infinity to 4. Now I'm going to solve some inequalities that are not linear, some polynomial. I'm going to use, find the zeros and use a sign analysis. And then I'm also going to show you how to do it on a graphing calculator. So first, I want to factor this polynomial. So it factors into an x plus 3, x minus 2. So the zeros are negative 3 and positive 2. So now I'm going to graph it on a number line. Okay? So you take your zeros, you factor it, you find your zeros, graph them. Now, you're going to pick something in each region. So this region, pick something in this region, pick something in this region. So pick anything, negative 4, negative 5, negative 99, doesn't matter. Make it easy on yourself. So negative 4. If I plug in a negative 4, I'm not really concerned on what that number is going to be. I just want to know, is it a negative or a positive? So if I plug in negative 4 plus 3 gives me a negative number. Negative 4 minus 2 gives me a negative number. A negative times a negative will give me a positive number. Is a positive number greater than 0? Yes, it is. So it's true. So it's true for everything in that region. So you can pick anything in that region. You put negative 3.1 and it'll be true. You pick negative 100, it'll be true. Now pick something in this region, any number. 0 seems to be an easy one. So when I plug in 0 for my x's, I have positive and a negative, which gives me a negative. Is a negative greater than 0? No, it's not. So it won't work for anything in that region. Now pick something greater than positive 2. Let's say 3. When you plug in 3, you get a positive times a positive. So it's true for anything in this region also. So now I can write my solution. I have my graph. It's really easy now. Negative infinity to negative 3, union 2 to positive infinity. So there's my solution. Next one. Factor the polynomial and find the zeros. So I'm going to factor x squared minus 4 factors into x plus 2, x minus 2, and x minus 1 is already factored. So my zeros are positive 2, negative 2, and positive 1. And now notice the graph. This I had open circles because that's a less than. Here I'm having closed because that's a less than or equal to. Okay? So there are my zeros. Let's do a sign analysis. So pick anything over here. Let's say negative 3. If I plug in a negative 3 here, I have a negative. Anything squared is going to be positive. So a negative times a positive gives me a positive. Is a positive less than or equal to 0? Nope, that's false. Now I'm going to pick something in between negative 2 and 1. Let's say 0. So when I plug in 0, I have a negative. When I plug in 0 here, I have a positive. And this is always positive because I'm squaring it. So that is equal to a negative. And that's true. Okay? So a negative is less than or equal to 0. Now, let's plug in something between 1 and 2. Let's say 1.5. So 1.5 minus 2 is a negative, a positive. Anything squared is a positive, which is a negative. So that's true also. So it works there too. And the very last one, I'm going to pick something greater than 2. Let's say 3. 3 minus 2 is a positive. 3 plus 2 is a positive. Anything squared is a positive. 3 positives multiplied together is a positive. This is false. A positive is not less than or equal to 0. So there's my graph. And now interval notation, let's write it in interval notation. Negative, whoops. That's not right. It includes negative 2, negative 2, and then it includes 1, so I keep going, and 2. And there's my solution. If those that was less than, and these were open circles, then it would be negative 2 to 1 union 1 to 2. But since they're closed circles, it includes everything between negative 2 and positive 2. Factor the polynomial, find the zeros. So I have x plus 3 quantity squared is less or greater than 9. FOIL. So I have x squared plus 6x plus 9 is greater than 9. Subtract 9 from each side. So I have x squared plus 6x is greater than 0. And then factor out an x. Oops, x plus 6. Okay? So x is 0, x is negative 6. So that's what I have. So now let's do a sign analysis. Negative 7. When I plug in negative 7, you have a negative times a negative, which is a positive. That's true. negative 1. You have a negative, positive, which is equal to negative. That's false. And let's pick something greater than 0. Let's say 1. Plug in 1, you have a positive times a positive, which is equal to a positive. And that's true. So there's a graph of your solution. In the interval notation, you would write it as negative infinity to 6, union, or sorry, negative 6, union, 0 to positive infinity. And there's your solution. Okay? And I'll have you write it in interval notation. The next one, this is already factored, the top and the bottom. But if it was not factored, you would need to factor the top, you would need to factor the bottom. So now, find the numerator, the zeros of the numerator, find the zeros of the denominator. So the zeros of the numerator are 3 and negative 4. Greater than or equal means closed circles for the numerator. So negative 4 and positive 3 is closed circles. 0 for the denominator is 5. But it can never be equal to 5 because then you'd have 0 in the denominator. So that the denominator 0 is always, always, always an open circle regardless of that. Okay, so there are my zeros. And now do a sign analysis, just like we've been doing. Negative 5. If you plug in a negative 5, you'll have a negative times a negative divided by a negative, which is equal to a negative. Is a negative greater than or equal to 0? That's false. Now plug in something between negative 4 and 3. Let's say 0. When you plug in a 0, you have a negative, a positive, a negative. This will give you a positive. It's true. So it works there. Pick something between 3 and 5, let's say 4. When you plug in 4, you have a positive times a positive over a negative. That's false. And something greater than 5. Let's say 6. When you plug in 6, you have a positive times a positive divided by a positive, which is a positive, which is true. So that is what the graph looks like. So now in interval notation, negative 4 to 3, and it includes both those, union 5 to infinity. And there's your solution. And you're done. Graphing calculator. Now let me show you how you can solve something with a graphing calculator. So I'm going to pull up my calculator. I am going to plug in my equation. And my equation that I'm using is right here. 2x cubed plus x squared minus 5x minus 2 is less than 0. So you go to y equals. First of all, in front of that, you'll have a line there. Look at, when I push enter, it changed to a dark line, so then it would plot it as a dark line. Pushing enter again, and now that's a greater than sign. Okay? There's a less than sign. Not sure what the 0 is. Dotted line, and back to my line. Okay? So here, you can think of this right here as my y. Okay? So you can think of it like that. So it's y is greater than that polynomial. So now let me just show you. Get a greater than sign there. Here's my greater than. And some of you can change it here with enter. The newer calculators, you might be able to toggle there, and you might be able to change it right in between it, not in front of it. Try to see what your calculator does. So I have 2x to the third power, so that little caret and a 3, plus x squared, minus 5x, minus 2. I can hit graph. You might not see the whole graph because of your window, but I do see my whole graph because of the window. The window's okay. So there's what my graph looks like. If I want to see a little better, it goes from -10 to +10. I can change my window. Let me just show you. I'm going to change my x first and show you what happens there. -5 to +5. Now I change the x, y. Or the x, not the y. Now I'm going to change the y. So let me show you what happens when I change the y. 1, 2, 3, 4, 5. I'm going to change it to 6 because I'm not sure if 5 will do it. So I'm going to do -6, -6 to +6. Okay? So now you need, what we had to do before is we found these zeros by factoring it. Well, your graphing calculator can find these zeros. You can go to calc, which is in blue, so second calc, and I want to calculate zeros. Left bound, so I'm going to find that 0 first. Enter. Right bound. There's right of it. Enter. And then enter again. It told me that that is -1.6 about. So this point here is -1.6. Let's find this 0 right there. So I'm going to calculate again. A 0. Left bound. Oops. So go left of that 0. Because it has 3 zeros here, so it wants to know which 0 I want to find. And now I'm going to go to right of that 0. Right bound. Enter. And enter again. And that tells me that it's about -0.4. So this point right here is about -0.4. And then the last 0, calculate. 0. Left bound. So I'm left of it, below it is left of it, enter. Right bound. So above it, anywhere above it. I don't want to go that high. There. Above it. I don't want to guess, enter. And that's 1.5. So this point here is 1.5. So now you can see with your graph that it's valid for anything less than -1.6 and anything between -0.4 and 1.5. I have the solution written, or an interval notation, -infinity to -1.6, union, -0.4 to 1.5. And that's how you use your graphing calculator.